The velocity in feet per second of a particle moving along the x-axis is given by the function v of t is equal to e to the t plus t e to the t. What is the average velocity of the particle from time t is equal to 0 to time t is equal to 3? So we have 5 answer choices in this type of question, and we need to determine which one of them is right. So the first thing to realize is that the average velocity is equal to the integral from 0 to 3 of the velocity function. This gives you the cumulative velocity, or the total velocity, because you're including all the times from 0 to 3, and then you need to divide that by the time frame, right? And the time frame is going to be 3 seconds, right? Because we're talking about from 0 seconds to 3 seconds. So 3 minus 0. So once you find the integral of the velocity function as a function of t, once you find the integral, you will simply divide this by 3, and then you will find the answer, right? So we're going to put the answer here. So how do we find the integral from 0 to 3 of the velocity function? Well, as you can see, the velocity function is given here. So the integral from 0 to 3 of v of t is going to be e to the t plus t e to the t dt. Okay, so that should be pretty easy, because you know the first one is easy to integrate. It's just going to be itself, e to the t, evaluated from 0 to 3. Plus, now you're going to need integration by parts, so let's talk about the u du v dv and then v. So u is going to be in this case the t, because you need something to differentiate that goes away eventually, and that's going to be t, right? Because the derivative of t is precisely 1, right? So 1 dt is the derivative of that. Now, this is going to be something to integrate for the integration by parts formula, and you know that it's easy to integrate e to the t, right? Because that stays to be itself, right? So et dt is going to be integrated, right? And the integral of that, the antiderivative, is going to be e to the t. Right? So now we know the formula is going to be u times v. So we can write that down, t e to the t, evaluated from 0 to 3, minus v du. Okay? So that's going to be minus integral from 0 to 3 of e to the t dt. So basically, you realize that this antiderivative of this is going to be simply e to the t, right? So why don't we just erase that, because that's going to be easy. So we know it's going to be just e to the t evaluated from 0 to 3, because the antiderivative of this doesn't change. It's always going to be that way, right? And the minus remains as it was on the left side of it. So now, as you can see, the only thing that remains is the middle guy, because these two are identical. You're subtracting one from the other, right? So you can cross that out. We don't need it. So as a result, what happens is just this. Evaluated from 0 to 3. So that's going to be what? First, you're going to plug in the 3 into the t. So that's going to be 3e to the third minus 0, right? 0 makes everything 0, so you don't need to worry about this power being 0 either. Well, it's going to be 1. Either the 0 is 1. 1 times 0 is 0, right? So the result is 3e to the thirds. So that is your numerator required for the average velocity, right? So that's going to be 3e to the thirds. Sorry, wrong power. 3e to the thirds divided by 3, essentially, right? So 3 go away, 3's go away, so you get e to the third. Now e to the third, should give you 20.0855 3692. So as you can see, the closest choice to this And keep in mind that this is feet per second, right? Because we're talking about the velocity. The velocity units are feet per second. So the closest number to this result is obviously going to be choice A. Right? So we know this is the correct answer to this problem. Thank you so much for watching. See you in the next video.